Instana GenAI Observability supports telemetry across major LLM providers and agentic frameworks, as well as host platforms like VLLM and GPU monitoring. It's quick to adopt with open source instrumentation built on top of OpenTelemetry. Once instrumented, you'll start seeing tokens, cost, and other performance-related data in the Instana platform. Here, we have an example of a watsonx application. In your code, all you need to do is add 2 lines to the top of your AI application code. This will instrument your app and start capturing various calls and deeper telemetry, like the actual inputs and outputs to the LLM-based system. If you have complex workflows, you can annotate specific function calls with the workflow decorator. Next, to capture accurate telemetry on tokens and cost, you need to install the OpenTelemetry data collector with the one-line install command. Once installed, you'll see a pricing configuration document. Here, you can set various cost parameters for the specific provider that you use. Some defaults are provided out of the box. From this point on, Instana will correlate health, quality, and cost for every GenAI call. This page is Instana's central view of GenAI across all your applications. You can see usage, cost, performance, and which models and services are running. Starting with the KPI tiles, you'll see things like input and output cost, the various models and services, as well as LLM calls that are being made. These give you a quick status update, how much you're spending today, how much you're using, and the size of your GenAI footprint. Combining this with the token and cost time series graphs, you can quickly spot abnormal consumption and tie dollars directly to the component responsible by breaking it down either by model or by service. LLM calls show traffic levels over time, so you can distinguish genuine demand changes from efficiency issues. And latency surfaces user perceived speed. Steady calls with rising latency typically point to a provider slowdown, cold starts, or some kind of configuration change. Finally, at the very bottom, you can see the model inventory. This allows you to identify which models and versions are present in your environment and where they're used. If you want to dig into actual inputs and outputs, you can open the Traces tab, where you'll see all the various traces, the input and output responses, as well as other things like tokens, duration, and status. If something looks off, you can click into a specific trace to investigate. In the flame graph, you can visualize the full reasoning path: tasks, agents, tool calls, vector lookups, LLM calls, and much more. So you can spot loops, identify the slowest step, and understand where tokens are consumed. For example, say the checkout responses have slowed down. In the flame graph, you may notice a retrieval span that repeats 3 times before an LLM call, each with rising token counts. That points to an agent retrying the same vector search, and all of this can be understood through the flame graph. These pre-built dashboards give you golden signals such as calls, error rate, and latency percentiles, which are correlated with GenAI usage and cost to confirm impact to the various endpoints present in the application. Overall, the GenAI observability product within Instana gives you a single place to monitor spend, performance, inspect prompts and models, and look at trace reasoning step by step, so you can quickly identify issues and troubleshoot them effectively.